All right, you guys, good morning. This is Mr. Ainsworth, and we're going to get into a cool lesson on parallel and perpendicular lines, and we're going to bring in the skills from our previous couple sections called point slope form and slope intercept and all that. So here we go. Let's get started, and let's talk about parallel and perpendicular lines and see what's the relationship between them. And then later on, we'll use the key ideas behind these. So we've got a few lines here. So let's label these lines. This is L1 and L2. So let's call this one L3 and L4. So these lines right here, they look like they're parallel and they act R. So L1 and L2 are parallel. But why? What makes them parallel? As opposed to, let's say, these lines down here, these are obviously not parallel because they're intersecting. All right, so what's the relationship between those lines later between two perpendicular lines? So we're going to start off with parallel first, all right, and determine the relationship between the two. What do they have in common? Let's write that down. What do they have in common? So what do parallel lines have in common? That's the first key question we've got to answer, and when we answer that, then we got it made. So let's take a look at this. Line 1, every line has slope and y-intercept, right? So the y-intercept is a little above 1/2. Don't know what it is exactly, but I noticed that the y-intercept is right here, and I noticed that they have different y-intercepts. Okay, so that's your y-intercept of line 1 right there, whatever it is, like a half or a little bit greater than a half. This one looks like it's around -4. But I notice one thing, that they do not have this in common. They have different y-intercepts. Okay, different y-intercepts. So they don't have that in common. I want to know, what do they have in common? So let's take a look at their slopes and analyze these. Okay, and we know that the slope of any linear function is equal to rise divided by run. A vertical change divided by a horizontal change. What is that? So what you do is you pick 2 points on the line and rise in one, run from one point to the other. So let's say we're at point A right here, and to get to point B, we can go up and right. So let's count. Okay, go up 2. Okay, 1, 2, and right 1, 2, 3, 4, 5. Okay, go right 5. And so the slope of line 1 is rise 2, run 5. So the slope of it is 2/5. Okay. And we'll call these points C and D. So how do we get from C to D on line 2? Well, we can go up 2, all right, rise 2, that's positive, and 1, run 1, 2, 3, 4. Oh my goodness, it's the same value. So the slope of L2 is also 2/5. So they have different y-intercepts, but they have the same slope. And so notice that right here, they have the same slope. Because of that, we can say that L1 is parallel to L2. L1 is parallel to L2. Okay, notice this symbol right here. Okay, that's your parallel symbol. Let's put it up here. The two parallel vertical lines are the parallel symbol. When two lines are parallel, they have the same slope. Or when two lines have the same slope, they're parallel. It's a biconditional. It goes both ways. Okay, so know that. Two lines that are parallel have the same slope. Even if lines have negative slope, if they can be parallel. So let's take a look at it. So from on line 3 here, we got, let's say, points E and F here. So how do you get from E to F? Well, you can go down and right. You can go down 4, that's a -4, and then right 1, 2, 3, 4, 5. So right 5. So the slope right there is -4/5 of line 3. Same thing here. So we can go from, let's say, G to H right here. We can go down, okay, and then right. So down 1, 2, 3, 4. It's a -4, and then right 1, 2, 3, 4, 5. So it also has the same slope of -4/5. So what does that tell me? It tells me that line 3 is parallel to line 4. Okay? Once again, this is your parallel symbol. It means parallel. Okay? So we can say that if two lines have the same slope, they're parallel, and we can also say if lines are parallel, they have equal slope. Okay? Or we can say two parallel lines or lines are parallel if and only if they have equal slope. lines are parallel, write it as a biconditional here, are parallel, all right, if and only if and only if, keywords here, if and only if they have the same slope. Okay, I'm going to use the word equal slopes. In a biconditional, we use the double arrow symbol. Okay, why? Because one implies the other. So if the lines are parallel, it implies they have equal slopes. That's from left to right. From right to left, if they have equal slopes, well, that means the lines are parallel. It's a biconditional. All right, that's your first basic fact about parallel lines. Now, the relationship between perpendicular lines is different. All right, so let's label these here too. So we got line 1 here, line 2, and then line 3 here, and then line 4 here. Okay, so the slopes. So let's figure out the slope of line 1. So from A to B, let's rise and run a little bit. So I can go to the right. Okay, 1, 2, 3, 4, 5, 6. So right 6. All right, and then up 2. So the slope of line 1 is 2/6 or 1/3. Okay, well obviously the slope of the blue line L2 is different. Okay, so to go from C to D, let's say, okay, you got to go down and right. So you count down 1, 2, 3, 4, 5, 6. Down 6, that's a -6. And then right 2, that's a +2. So for line 2, it's different. It's -6 divided by 2 or -3. So you can see that the slopes are different. That's pretty darn obvious. All right, so perpendicular, the symbol for that is the upside down capital T, or the 90-degree angle symbol that you see in your lesson here. That's 90 degrees. I'll put 90 degrees right there. So perpendicular lines form 90-degree angles. Okay, you should know that from basic or back in, I don't know, either elementary school or middle school. So these perpendicular lines form 90-degree angles, but more than that, their slopes have this very special relationship. And before I talk about that, we're going to go to graph number 2 here. We're going to figure out their slopes and then take a look at them and compare. All right, so over here, let's say that this is point E here and this is F here. So from E to F, you can go down and right, or you can go right and down. It doesn't matter. So if you go down 2, and you're going to have to go right 2. Okay, so line 3 has a slope of -2 divided by 2, or -1. Okay, now the slope of line 4, that's different. You got to go up 2, okay, right 2. And so the slope of that one is 2 divided by 2, or 1. So the big question here is, what is the relationship between these slopes? What is the relationship, all right, between the slopes? Now, if you can answer that question, then you can answer the main question. What is the relationship between perpendicular lines? The first thing you got to figure out is, what's the relationship with these slopes? I'm talking about 1/3 and -3. I'm talking about -1 and 1. What kind of numbers are these? What kind of numbers are these? Okay. Notice the one's positive, one's negative on both cases here. So they're definitely opposites, but they're more than that. They're opposite in sign, but not opposites. So there's a big difference there, okay? Because the opposite of -3 is +3, and that's not what I see up here. Over here, -1, they're opposites, but over here, they're not quite opposites. They're opposite in sign, but they're also reciprocals of one another. Okay, so we call them opposite reciprocals. Opposite reciprocals. Now, another name for that is negative reciprocals. So you could say opposite reciprocals, okay, or you could say negative reciprocals. Either one. It's depending on your teacher and what class you've were in the past and who taught you here. You could say either one. They're interchangeable. Okay, which means if you know one, you know the other one. Okay, so two lines are perpendicular if and only if their slopes are opposite reciprocals. All right, so two lines are perpendicular. Here we go. If and only if. So if and only if their slopes are opposite reciprocals. Their slopes are opposite reciprocals. Okay, and once again, it goes both ways. Meaning that if you start here, if you have perpendicular lines, you can assume the slopes are opposite reciprocals. Or if you are given the fact that they're opposite reciprocals, you can assume the lines are perpendicular. Okay? That again is a biconditional. So if you know one slope, you can find the other. You just take the opposite reciprocal of it. If you have parallel lines, well, that's much different, right? If you have parallel lines, they have equal slopes. Holy cow, that's totally different. Okay, so the slopes there are the same. All right, so knowing this fact, we can solve all kinds of problems. Okay, here's a basic one. This one you'll see next year as well in geometry. And it deals with a quadrilateral, which is a four-sided figure. Okay, quad means four, lateral means side. So this is a four-sided figure. All right, and this quadrilateral, the first one you'll see here, and it's called PQRS. It's, the question is it a parallelogram? A four-sided figure where opposite sides are parallel. Is it a parallelogram? Is it not? To do that, you got to find the slopes of all four sides. So you have to do this right here. This is your goal. You got to find the slopes of all four sides and compare them to see if it is actually a parallelogram. Okay, so let's do that. All right, let's find the slope of PQ. Slope of side PQ. So to name a side of a figure in geometry, use the endpoints, okay? And you put a little segment on top because it's a segment, not a line. So the slope of PQ, rise over run. Remember that slope equals rise divided by the run. All right, vertical change divided by the horizontal change. Okay, so on this one here, to get from P to Q, you can go down and right, or you can go right and down. So if you just go right 4 units and then down 2, you can see the slope of it. So the slope right here is 2/4 or 1/2. So 2/4 equal to 1/2 is its rise over run. Now, we're going to see if it's parallel to SR, this other side. I want to check to see if these two sides, SR and PQ, are parallel. So I'm going to work on the opposite side. So slope of SR, which is its opposite side. If it's the same, then these two sides are parallel. So let's check it out. I can go down 2, which is a -2, and then right 4. Ooh, I made a mistake on the previous one here. Down 2 is a -2. That means I get a -1/2. Okay, these have negative slope. I'm sorry. So down 2 is a -2. So -2 divided by 4 is -2/4, so we're -1/2. I noticed my little mistake because I went down here too, and that's a -2. And then right 4, that's +4. So the slope of SR is the same, -2/4, or -1/2. So what this is telling me, it's telling me that PQ and SR are parallel. Side PQ is parallel to side SR. Okay? Now to be a parallelogram, all right, both pairs of opposite sides must be parallel. Both pairs, okay, of opposite sides must be parallel. Let's highlight that. So it's not enough to check one pair, you got to check the other pair. So that's step 1. Now we got to go to step 2. We got to look at these other pairs. Okay, so side PS. So the slope of PS. Side PS. So to get from P to S, you can go down 3 and then right 2. So on that one, it's -3/2. Okay, no need to simplify there. Okay, now let's take a look at the slope of QR. Okay, to get from Q to R, you can go right 2, down 3. Okay, and same thing, negative 3 halves. There we go. And because of that, that tells me that these two sides, PS and QR, are parallel. So side PS is parallel to side QR. Now, because both pairs of opposite sides are parallel, then the quad is a parallelogram. So because both sides, both pairs, okay, we're talking about two pairs here, of opposite sides are parallel, okay, quad PQRS, it's always just pick a point and go clockwise, okay, PQRS is a parallelogram. Parallelogram. Okay, so we do the math here, and then you got a conclusion. You always have to state the conclusion. Okay, it's an important thing. Just like in English, you have to write your final paragraph, your concluding paragraph. Well, the same thing in mathematics. You do your math, which justifies your results, and your result or your conclusion is as follows. Okay, so because not all quads are parallelograms. Some are trapezoids, some are just regular four-sided figures. So you got to actually think about it. Okay, so back up here, is it a parallelogram? Yes, it is in this case. Okay, down here, I don't know, let's check things out. Okay, so we got to analyze is side JK and ML, are these two sides, I'm talking about this one here. Let me highlight this one and this one, are they parallel or not? So let's figure it out. So slope of JK, got to figure that out. You got to find the slope of ML, you got to see if these are the same or different. So you rise and run. So from J to K, you got to go up 1 and then right 1, 2, 3, 5. Okay, so up 1, right 5. That's the slope of 1/5. Okay, over here we got to go up 1 right here. It's pretty obvious. And right 1, 2, 3, 4, 5, 6. Okay, that's 6 right here. So here the slope is 1/6. So I can already tell, all right, that side JK, this one here, your first side that I took a look at, is not parallel. Okay, when you slash it, it's not parallel to LML. And because of that, this quad, okay, quad JKLM, so JKLM, okay, is not, okay, a parallelogram because it requires both sides, not one pair, but two. It's not a got to spell this right here, parallelogram. Not. Okay, and that's all there is to it. If they found that the first pair was parallel, then I would continue and I would test the other pair, but I already found that these two are not parallel because they have different slope. Okay, now let's get to the algebraic piece. Ooh, fun times. Here we go. Goal number 2. Let's find the equation of a line that is parallel to a given line. Okay, so here we go. Keyword parallel. But we want to find the equation of it. Okay, so here we go. So they give us y equals 2/3 x minus 2. And we got to go through the point 1, comma 2. So let's graph this situation here just first so we can get an idea. So down here, -2. All right, and this is up 2, right 3 from that point. So up 2, right 3, up 2, right 3. Let's reverse it and go down 2, left 3. All right, and draw your line. So it's always good to do this with a straight edge. And then I'm going to label this. Y is equal to 2/3 x minus 2. Okay, now point 1, comma 2 is right 1 up 2. It's right here. So that's 1, comma 2. So I need to find the line. Okay, it looks kind of like, right around in here somewhere. Okay, find a line there that is parallel to this one. the first one they gave us, and it's going to have a different y-intercept because it's going to intersect, I don't know, so let me see, up to 2/3, up 2/3, yeah, 2, down 2 right there. So here it goes like this. It's going to have a different y-intercept, look at that, than this one. This one's at -2. This one, it's probably going to be around 1 somewhere. We got to figure it out, right? So we know that it's parallel. Okay, that means it has the same slope. Okay, now the slope here is 2/3. So I'm going to use, okay, the slope of 2/3, and I know that my point in question, x1 comma y1, is 1 comma 2. And I want to use point slope form. Point slope form here. So I go y minus y1 equals, all right, m times x minus x1. And what I want to do is substitute my point in. Okay, x1 is 1, that goes here. And then y1 is 2, and that goes here. And my slope, I already know it, it's 2/3. Okay, so I have y minus 2 is equal to 2/3 times my x minus the x value, which is 1. Okay, distribute through. Y minus 2 is equal to 2/3 x minus 2/3. And you got to distribute twice, right? Okay, and then I have to add 2. So y is equal to 2/3 x. And 2 minus 2/3, 2 minus 2/3 is 1 1/3. So plus 1 1/3. So the slope of the line is 2/3. The y-intercept here is 1 2/3. Excuse me, 1 1/3. Okay, I knew it was going to be close to 1, but I didn't know what it was exactly going to be. Okay, so now let's plot. Let's go up 1. Let me see. Let's plot 1 comma 2. Actually, plot 1 comma 2. Let's put that back. There it is. And it's got a slope of 2/3. So up 2, right 3. Let's reverse it. And down 2, left 3. Down 2, left 3. And let's draw the line. And you can see that this right here, that's a little bit above 1. It's 1 1/3. There's your y-intercept. So what we did makes sense. This makes sense right here, because when you graph this, which I just did, okay, this is our point 1 comma 2 right here. As according to the directions here, it has to go through 1 comma 2. And it has to be parallel to the given line, which it is. You can tell it looks parallel here. It never touches, right? Because it has the same slope. It has a different y-intercept, but it has a different slope. So your goal is to find the equation line and then graph it and then make sense of it, okay? So now what you guys got to do is the same thing. So let's pause and play the video here. So if you're doing this at home because you're not at school, pause and play. Pause it right now. Work through example 5 and then press play and check it, okay? So go ahead and do that. Pause the video and get started. Okay, let's check your work. Let's graph your line first. Okay, so we're going to start at 3. Then we're going to go down 3, right 4. So down 3, right 4. Let's graph your line here. Okay, so there's your first line right here. That is, oh, well, I can't put it there. That's your given line. Okay, and it goes through 0, -1. 0, -1 is right here. 0, comma -1. It's right there. There we go. All right, and now let's find the equation of it. So y minus y1 is equal to m times x minus x1. You always write down your point slope form, and we're substituting in for the point here, and I need to substitute my slope in right here. My slope is -3/4. So y minus the y coordinate, which is 1, excuse me, -1, is equal to negative 3/4 times the quantity x minus the x coordinate of 0. Okay, let's simplify. Y plus 1 is equal to negative 3/4 times x. Okay, x minus 0 is just x times negative 3/4 is just negative 3/4 x. Subtract 1 and you're done. So you get y equals negative 3/4 x and then minus 1. All right, now this line here has the same slope as this line. So from 0 comma negative 1, we're going to go down 3, right 4. So down 1, 2, 3, down 3, right 4. 1, 2, 3, 4. Okay, so now let's reverse it. Let's go up 3. 1, 2, 3, left 4. 1, 2, 3, 4, right here. Now take your straight edge out, and let's see if this line makes sense. Okay, and notice right here. Right here. That's a y-intercept. And the y-intercept's 0, negative 1, which makes sense. This is your y-intercept of negative 1. And this right here is your slope. So when two lines are parallel, they have the same slope, but different y-intercepts, which makes sense. And what you're going to use is point-slope form, as I said earlier here. Okay, I always use point-slope form. Okay, that right there is in section 5.4. Okay, and I spent actually 2 lessons on it. So this is where it's going to start paying off right here. You have to be able to find the equation line either parallel or perpendicular to it. Okay? All right. Now let's switch to perpendicular and see what happens. This one's different, okay? Here we want to find the equation line that is perpendicular to the given line. Okay? So let's graph the situation first and then we'll interpret. Okay, so we're going to find the equation that is perpendicular here to this line here through 0, 3. So starting at 3 here, that's your y-intercept. Slope negative 3/4 is down 3, right 4. Okay, so let's graph that line here. Okay, and then our point in question is 0, 3, which is right here. 0, 3. So our perpendicular line, somewhere in kind of probably looks like that, right through there, because you want to form a 90-degree angle between the two lines. Okay, so let's erase that, and let's find it. Let's write down point-slope form. Y minus y1 is equal to m times x minus x1. x1 is 0, y1 is 3. But here we got to be careful because we don't use the same slope. Let's go back to the beginning. Okay, right here, and when I talked about perpendicular lines, okay, we found that their slopes are not the same. They're not even close. I mean, look at our examples right here, right? They're not only opposite, but in sign, but they're also reciprocals. So we found that they were opposite reciprocals. Right here, slopes are opposite reciprocals. Okay, so let's go back to our example right here, and we got to take the opposite reciprocal of 3/4. So opposite reciprocal of negative 3/4, what is that? Well, it's opposite of a negative is a positive, so it's positive, and the reciprocal of 3/4 is 4/3. All right, so we want to use m equals 4/3. So we're going to use m equals 4/3, the opposite reciprocal of the given slope. And we're going to use this point here. That's a key concept right there because they're perpendicular. So here we go. Y minus the 3 here is equal to not the original slope, but the opposite reciprocal slope, which is 4/3 times x minus the 0 here. So simplify, we get y minus 3 equals 4/3 x. All right, add 3 and you're done. So you get y is equal to 4/3 x plus 3, where this is your slope and this is your y-intercept. So let's make sense of it. Let's plot 0, 3, it was already plotted, and let's use 4/3 as your slope. So we're going to have to go up 4, right 3. Up 4, right 3. We'll reverse that. Okay, make them both negative. and go down 4 left 3, which is what we're going to have to do because we're off the graph. Okay, so instead of going up 4 right 3, we're going to go down 4 left 3. So down 4 left 3. 1, 2, 3, right here. 1, 2, there we go. So this way. This will, using the slope in reverse, will allow us to stay on the grid and graph our line. Okay, and there we go. And not only that, look at that. They look like they're 90 degrees. They're perpendicular. So this is this line here is y equals 4/3 x plus 3. All right, it goes through 0, 3 as we wanted it to, and it's perpendicular to the given line. Now it's your turn again. So at this point, I want you to pause and play. All right, interact with me. Go ahead and work through it, and when you're ready, press play. All right, let's check your work. Let's graph the situation here first. So let's plot the y-intercept to 2, and then from there go down 1, right 2. So down 1, right 2, down 1, right 2. Reverse it, up 1, left 2, up 1, left 2. Okay, and let's draw the line. Okay, it has to go through x1 comma y1, it has to go through -1 comma 0. -1 comma 0 is here. That big blue dot there. All right, and so let's find the slope first. So the slope here is -1/2, and so the opposite reciprocal, okay, of -1/2 is 2. 2 over 1 is 2. Opposite of a negative is a positive. Reciprocal 1/2 is 2. So I want to use the slope equals 2. So y minus y1 is equal to slope times x minus x1. Substituting my information in, I got y minus 0 is equal to 2 times x minus a -1. Simplify, you get y is equal to 2 times x plus 1. I see a double negative right here. That double negative is a positive. Distributing the 2, I get y is equal to 2x plus 2, where 2 is a slope, and this is the y-intercept here. Okay, so now we got the y-intercept right here. Slope of 2 is the same thing as 2 over 1, which is up 2, right 1. So up 2, right 1, up 2, right 1. Reverse it, down 2, left 1. Okay, and then let's draw the line. There we go. And it's indeed, there's a right angle here. It's 90 degrees in between these two. Okay, you can check with the index card, just fit it between the two lines. You know, because the index cards are rectangular, and in rectangles, all the angles are 90 degrees. So if you can fit an index card in there, you know it's 90 degrees. Okay, all right, and that's the second or the third goal in the lesson here. So at this point, you just got to get good, right? So that means you have to try it on your own. So once again, once you pause the video, all right, and play when you're ready. I'm serious. Pause the video now. Okay, checking your work. Okay, parallel lines, same slope. So there's the slope right here. All right, -3 over 1. All right, so here we go. Starting at 1 right here, and then a slope of -3 would be down 3, right 1. Reverse it, up 3, left 1. Draw your line. Okay, next one, we got to plot 3, 0, which is here. And we got to find the equation of the line. So y minus y1 equals m times x minus x1. Here we go. Y minus 0 is equal to the same slope. All right, -3. So -3 times x minus 3y because x1 is 3, right? y1 is 0. So simplify, you get y equals negative 3 times x. Well, I got to distribute. Negative 3 times x is negative 3x plus negative 3 times, negative 3 is positive 9. All right, and there's your slope and there's your y-intercept. Oops. Okay, it's off the graph. Oh, okay. So what do we do? Okay. So from the slope here, negative 3 over 1. So from this point, go 3 comma 0, go down. Well, instead of doing this, let's go 3 divided by negative 1. There we go. So let's go up 3 and then left 1. Reverse the slope. Okay, so from here we go 1, 2, 3, right 1. Excuse me, left 1. Go up 3, 1, 2, 3, left 1. Up 3, 1, 2, 3, left 1. And guess what? If you extend the y-axis up here, get your ruler out and extend it. There we go. And count 1, 2, 3, 4, 5, 6, 7, 8, 9. It's at 9. Holy cow. Okay. Okay, even I got it. Even though it was off the grid, I got it. Okay, so this makes sense. All right, because it intersects at 9, and that's what the y-intercept is. Okay, so yeah, okay, it's off the grid, but no big deal. All right, now perpendicular situation here. We want a perpendicular through 1 comma 0. Okay, so we want the opposite reciprocal slope. So here the slope equals 1/3. Opposite reciprocal. Okay, well that's negative 3. Opposite from positive is negative, and the reciprocal of 1/3 is 3. So we want to use m equals negative 3. So here we go. Y minus 0 is equal to negative 3 times x minus the 1. Okay, you got to substitute your point in. This is y1 and this is x1. Given our point here, this is x comma 1 comma y1. Excuse me. So simplify. Y is equal to negative 3. All right, x plus 3. So we're done algebraically here, but let's graph. So in this function here, we start at 3 with the slope of 1/3. Reverse it, left 1, down 3. Excuse me, down 1, left 3. All right, graph the first line. Now we want it through 1 comma 0, which is right here. So from that point, we're going to go down 3, right 1. So down 3, right 1. Now let's reverse it. Let's go write it as 3 divided by negative 1. So we'll go up 3, left 1. Let's reverse it. So we're going to go up 3, left 1. Up 3, left 1 right up here. And then draw that line. There we go. So that's a right angle there. And you can put it 90 degrees in here. Why? Because it's perpendicular. Okay, 90-degree lines. Okay, lines at 90 degrees to one another are called perpendicular lines. So you want to look for that right angle symbol. Okay, parallel lines never intersect because they have the same slope, different y-intercepts. But perpendicular lines always form right angles to one another. Okay, and that, my friends, is it. The only thing you need to do is get real good. Okay, and that means that you have to go to the beginning here, take out your textbook, and actually practice. Okay, and do this in your spiral. Or if I gave you something on the back of this, you could do it on the back of this lesson here. Okay, your choice. Okay, so do it in a spiral or on the back of the lesson. Your choice. All right, now since the video, remember, you can also pause, play, rewind, go back, and listen to any portion you want, okay? But take good notes, work really hard, do your homework, check your homework in the back of the book. Check homework in the back of the book. Be smart about it. All right, be a good student. All right, and I'll see you in my next lesson. This is Mr. Ainsworth. I'm out of here. Bye-bye.